Today we're going to do some guided practice on an exam question. This is the 2004 atomic structure question, and what came up on this was Bohr's theory. This was a half question. In total, there are 25 marks on for this question, and 25 marks means we have about 10 minutes to complete. So again, start your timer and go for, try and keep it under 10 minutes. All right, so the first question is worth 13 marks, okay? So remember that most points you give in the exam are worth 3 marks. So 4 by 3 is 12. So we're probably looking for between 4 to 5 points. Yeah. Okay, 4 to 5 separate points. So in part B, or in this part here, we're asked to describe how Bohr used the line emission spectra to explain the existence of energy levels in an atom. Okay. So what he's really looking for here, what's he looking for? Well, he's looking to see, okay, how do the different lines on the emission spectra prove that energy levels exist? Now, because he's looking for 4 to 5 points, we really need to talk about how Bohr's theory links to emission spectra. Okay, so we're going to be talking about Bohr's theory, proving energy levels exist, and taking into account the spectrum. Quite a lot going on here. So we're looking for 4 to 5 points about Bohr's theory and how in the end it leads to emission spectra forming and how that proves energy levels exist. Okay, so go ahead and pause the video and have a go at that. Okay, so you should only be watching the video if you've written down 4 to 5 points here. So we begin by saying, okay, so in an atom, electrons normally occupy the ground state or are found in the ground state. So electrons usually in the ground state. Electrons are usually in the ground state, but they don't always stay there. Sometimes they can jump. Okay, so they can jump. Okay, if you didn't get this, pause the video and finish off this sentence. Okay, so they can jump where? They can jump to a higher energy level. By absorbing energy. Again, if you didn't get this, so you didn't know how to start this, I've done the first two. Pause the video and see if you can do the next couple of points. Okay, so show me following if you've tried to answer these 5 bullet points. Okay, so what happens once they jump to a higher energy level? Well, we call them excited electrons now, and these excited electrons are unstable. So what happens to them? They fall back to the ground state, I suppose, if you like. Or maybe not to the ground state. They fall back to a lower energy level. What happens when they fall back to a lower energy level? Okay, so you should be talking about light here in the next bullet point. If you haven't talked about light, you need to do that now. Pause the video and do that. Okay, so so they fall back. So this should say they fall back to a lower energy level and they emit specific frequencies of light. Okay, when they do. So they give off the energy as light. And the last bullet point, you need to link now, how do the specific frequencies of light give rise to the fact that does this prove that energy levels exist? So again, if you haven't done this, pause the video and do this now. Okay, well, what causes there to be specific lines? Well, we would say it like this: the energy difference between the two energy levels So this is how we prove that there are energy levels. So we definitely want to be mentioning energy levels here. Gives specific lines on the emission spectrum. All right, so I've got lots of time. I'm going to pause and read back over my answer and make sure it makes sense. So what have I said? How does Bohr's theory prove that energy levels exist? And we need to talk about the spectrum. So electrons are usually in the ground state. They can jump to a higher energy level by absorbing energy. Excited electrons are unstable. They fall back to a lower energy level and they emit specific frequencies of light. The energy difference between the two energy levels that they've moved between gives specific lines on the emission spectrum. Pretty happy with that. I'm pretty happy I'm going to get all the marks there. Next one. Why does each element have a unique line spectrum? Okay, so what makes them be unique? All right, so that's the next question. Why do elements have unique emission spectra? Emission spectra. Okay, so what I want you to do is I want you to pause the video and I want you to try answering that for me now. Okay, so Sean, we're watching if you've tried to answer that question. So what makes elements have unique emission spectra? Well, remember emission spectra are caused by electrons. So what is different about different elements and their electrons? So what's different is that each element has a different electron configuration. And if they have a different electronic configuration, well, that means we're going to get different electron transitions. This results in different transitions of electrons. And transition, this word we looked at before, this word just means electrons moving between energy levels. Okay, so different configurations means lots of different transitions happening. And it's the transitions we know are what takes in energy and gives out energy. And that's where you're seeing these colored lines. So this results in different transitions. So because every element's got a different number of electrons in different shells, when they're moving up and down the different transitions, you're getting different bands of light. Okay, all right, next one. The fact that each element has a unique line spectrum forms the basis for an instrumental technique, which can be used to detect heavy metals and to measure their concentrations in soil or a water sample. You just have to name this instrumental technique. The instrumental technique that uses spectra. Okay, so hopefully name a technique. Go ahead, pause the video and name the technique. Okay, so hopefully you said atomic. Okay, and if hopefully you can finish that off. If you didn't get started, I'll give you the first bit, pause it and finish it. Okay, it's atomic absorption. Again, pause it if you didn't get it. Spectroscopy. Okay, so atomic absorption spectroscopy, that's the technique. All right, next one. Bohr's atomic theory was later modified. Give one reason why the theory was updated. So for 3 marks only, we just need one thing. I would often go 2 things. So these are what we call the limitations of Bohr's theory. Why was it modified? Well, because it was limited in certain ways. Limitations of Bohr's theory. We learned a few of these. So if you can remember more than one, it won't take long to write down more than one, and just make sure you're writing one they'll accept. So pause the video, do that now. Okay, a couple of reasons. It only worked for hydrogen. Only worked for hydrogen. and doesn't account for a few things. Doesn't account for. Can you remember what it doesn't account for? Pause the video, write it down if you didn't get them the first time. Okay, so it doesn't account for two things. The first one is wave particle duality. And the other one was the Heisenberg uncertainty principle. Okay, so we've got more than enough there. We only needed one, but we're just taking care. We didn't take long to write that extra stuff down. We knew it, so we may as well make sure we get the marks. All right, so pause your timer now. Hopefully we did that in less than 10 minutes, and now we're correcting. Okay, so we're using the marking scheme over here to correct. All right, so let's have a look here. As you can see, part B, we're describing how Bohr's theory proved energy levels exist by talking about the spectrum. So here we go. What have we said in the first point? Electrons usually are in the ground state. So what does it say over here? Electrons are usually in the ground state. So this is the first 4 marks. Okay, so that's a 4 here. We're getting 4 marks for that. That's correct. Then we've said they can jump to a higher energy level. Jump to a higher energy level by absorbing energy. Let's see, is that point in the second 3 marks here? Fixed energies, they can jump to a higher energy level or an excited state. Good. So there's the second 3 marks. 3. The next one, excited electrons are unstable. They fall back to a lower energy level. Let's see what we got here. 3. Excited electrons are unstable. They fall back to lower energy levels. We only needed one of them. So excited electrons are unstable. There we go. We just needed that. And we got 3. We also would have got it for this if we didn't say excited electrons are unstable. If we said they fall back to a lower energy level instead, we would have got the 3 marks for that. What about the last one? Energy difference between levels gives specific lines of light on the spectrum. What have we said over here? Energy difference between the 2 energy levels gives specific lines on the emission spectrum. All right, so almost word for word, not exactly, but almost. That was the last 3. So far on that little section, we got the 13 out of 13. Next one, why do elements have unique emission spectra? So what have we said? We said that each element has a different electronic configuration, and this results in different transitions. Okay, so let's look over here. Each element has a different distribution. Well, we used this one over here, different electron configurations. So each element has different electronic configurations. Okay, so that's the first 3. Giving rise to different electron transitions. You see in bold, that's the bit that's needed for the second 3. So we have both of them. Each element has a different electronic configuration. That was 3. And this results in different transitions. That's the second 3. Next one, name the technique. So what is the correct technique? There it is, atomic absorption spectroscopy. There it is. So in blue, I'm highlighting here, and that was for 3. So atomic absorption spectroscopy is what 3. And the last one, limitations of Bohr's theory. Why was it changed? Why was it updated? So as you can see, we only need one of these things here. So it only work for simple atoms like hydrogen, and I could say it only work for hydrogen. Doesn't take the wave particle duality or wave nature of electron into account. Heisenberg uncertainty principle. Discovery of sublevels, doesn't take sublevels into account. There's a couple of other things as well, but they're the main ones we learned, and we only need one of them. So we have more than enough here. So again, we're taking it for the 3 marks. Again, we didn't lose any marks there. So this is going to be 25 out of 25. This is 6.25% of the paper. Okay, done in 10 minutes. All right, guys. So that's that question. Again, thank you for sticking with me. It's really important that you don't just do the question, that you do stick around, check the marking scheme, make sure you're getting the accurate language, because it's really important. All right, we'll see you in the next video.